This is Miss Humbert here. Today we're going to be doing Unit 2 Learning Target 4. So we're going to be talking about graphing and writing systems of inequalities. So here we're going to have to make sure that things are solved for y. So that's one of the biggest things when you're graphing inequalities, and if they're in standard form, in order for us to be able to graph them, they need to be in slope-intercept form, which means that they're solved for y. So you can graph the inequalities once they're in slope-intercept form, and that's exactly what we did on the previous note sheet. So let's go ahead and let's take a look at that. So first of all, for number 1, we're going to have to do some solving, to get that into slope-intercept form, okay? So I'm just going to drag that over to give myself some more space. So I'm going to start by solving that first one. So I have x plus y is less than 1. So I'm going to subtract x from both sides, and I get y is less than negative x plus 1. Okay, so I'm going to go ahead and graph that. I'm crossing the y-axis at 1, then I'm going down 1, right 1, down 1, right 1. And so I'm going to go ahead and have a dotted line. So if you're still struggling to make some of those decisions like we did on the previous note sheet, please let me know. The alligator's facing away from the y, so I'm going to go ahead and shade down. So for the next one, I have negative 2x plus y is less than or equal to 3. So now in order to solve that for y, I need to get that 2x over to the other side. So I'm going to go ahead and add 2x to both sides. Okay, so then I get that y is less than or equal to 2x plus 3, okay? So we're crossing the y-axis at 3, so I'm going to go ahead and draw that. And then my slope is 2, so that means I'm going up 2 over 1, up 2 over 1. So I notice there's a solid line underneath that inequality, which means I'm going to have a solid line for my graphing. Since it's facing away from the y, I'm going to shade down. Now we want to make it really clear where our overlap is, so I'm going to shade that in. If you want to use different colors on your worksheets, you absolutely may. So that's our final answer for number 1. Now, let's take a look at number 2. So for number 2, I notice that it's already in slope-intercept form, so I can actually go ahead and graph it. So for this first one, I'm crossing the y-axis at 1. And then my slope is 1, so that's up 1 over 1, up 1 over 1. So then we're going to go ahead and we're going to have dashes through it. Okay, so since the alligator's facing the y, I need to shade up. So let's take a look at that next line. So I'm crossing the y-axis at a negative 3, and again, my slope is 1, which is the same as 1 over 1. So up 1 over 1, up 1 over 1. So I'm going to go ahead and I'm going to make it dashed. And then I notice that the alligator is facing away from the y, so I'm going to shade down. So here I notice that there's no overlap, which means I have no solution, since we have no overlap. So that's our answer for number 2. Now let's take a look at number 3. So for number 3, again, we need to solve these so that they're in slope-intercept form. So I'm going to start with this first one. So I have 3x minus y is greater than or equal to 6. So I'm going to start by subtracting that 3x over to the other side. Then I get negative y is greater than or equal to negative 3x plus 6. Now this is really important. We don't want to have it be negative y. We actually want that to be positive. So I'm going to go ahead and divide both sides by a negative 1. Now if you're thinking back to when we first started inequalities, you'll remember that when you divide an inequality, when you divide both sides by a negative number, you need to flip that symbol. So I'm going to go ahead and do that. Negative 3x divided by negative 1 is going to become a positive 3x. 6 divided by negative 1 is going to become a negative 6. So I'm going to go ahead and I'm going to plot negative 6 on the line. Okay, so that's my y-intercept. So then my slope is 3, or 3 over 1. So I'm going up 3 over 1, up 3 over 1. So then it's going to be a solid, oops, that is a terrible, terrible line. So we're going to have a solid line going through those points. Okay, so then I'm going to be shading down. I need to look at my final answer, and I notice that it's down. Okay, so I'm going to go ahead and shade that one. So next, I have 2x plus y is less than or equal to 4. So I'm going to go ahead and subtract 2x from both sides. And then I get that y is less than or equal to negative 2x plus 4. Okay, so we're going to cross the y-axis at 4. And then we're going down 2, right 1, down 2, right 1. And we can go ahead and we're going to draw a solid line through that. And again, I'm facing away from the Y, so I'm going to shade down. And I want to shade in color to make it really obvious, or just shade it really dark to make it really obvious where your final answer is. So that's your final answer for number 3. Now, let's take a look at number 4. So for starters on number 4, I see that I have a thing that's just an X. So remember, when a thing is just the X, we're going to have a vertical line. So we're going to cross the X-axis at 3. Since there's a solid line underneath the inequality, my line is also going to be solid. So there's that line. Okay, so then we want it to be smaller than 3. So if we look at the X-axis as a number line, it's getting smaller as we go to the left. So that's that top one. So now we need to take number 4 and we need to solve that second equation so that we can get y by itself. So to do that, I'm going to subtract x from both sides. Now I can't combine the 2 and the x because they're two different things, okay? So then I'm going to have a negative x plus 2. So I'm going to go ahead and graph that. I'm crossing the y-axis at 2, and then my slope is negative 1. So down 1, right 1, down 1, right 1. So then I'm going to have a dashed line, and we're going to be shading above that. So then my solution is just what's left in this little corner right here. So that's all there is to graphing systems of linear inequalities in standard form. So a lot of times, if you remember, we use standard form to set up word problems, okay? So what I'm going to do is we're going to go ahead and we're going to set up some of these word problems. So I'm just going to move this out of my way so I have a little bit more working space. Okay, so it says the most Jack can spend on bagels and muffins for the cross-country team is $28. A package of 6 bagels costs $2.50. A package of muffins costs $3.50 and contains 8 muffins. Okay, so he needs to buy at least 12 bagels and 24 muffins. So let's start. One of our first things that's going to limit us is the price. So for every X thing of bagels I buy, it's going to cost me $2.50. For every Y things of muffins, it's going to cost me $3.50. And that needs to be less than or equal to 28. Okay, so let's go ahead and let's solve that for Y. So I'm going to start by subtracting 2.5x from both sides. Okay, so then I get that 3.5y is less than or equal to negative 2.5x plus 28. So now I can divide both sides by 3.5. Okay, so when I do that, I'm going to get a weird decimal for x. So let's just start by writing that down. So the weird decimal I get is negative 0.71. We'll talk about that in a second. And then 28 divided by 3.5 is going to give me 8. So let's start by graphing this one right here. So we're crossing the y-axis at 8. So I'm going to count up to 8. 1, 2, 3, 4, 5, 6, 7, 8. So here's 8 right here. And then my slope basically is a negative 0.71 over 1. So I'm going to go almost all the way down 1 and over 1. Almost all the way down 1 and over 1. Okay, so it's not going to be exact because of our decimal here. Now that's going to be a solid line. And we want to shade beneath that because we want it to be less than or equal to. So that's one of our lines. Okay, so I'm just going to erase that so we can go ahead and get started on our next line. So our next line, let's just take a look at bagels. We want to have at least 12 bagels, okay? So for every X container of bagels I buy, I'm going to get 6. And I want to have at least 12. So that means if I have more, that'd be great, but I might not, okay? So then I'm going to divide both sides by 6, and I get that X is greater than or equal to 2. So again, that's going to be one of those vertical lines. So I'm going to cross the y-axis at 2. And then I'm going to have a solid vertical line going up through that. Okay? Then I want it to be greater than that, so I'm going to be shading off this way. Because if I have more, that would be awesome. Now this one's going to have a third one because we need to figure out muffins. So for every X pack of muffins I buy, I'm going to get 8 of them. And I need to have at least 24. If I had more, that would be awesome. Okay? So then I'm going to divide both sides by 8. And I get that X is greater than or equal to 3. Or sorry, Y. That should be a Y because muffins are Y. Okay, so now we're going to find 3 on the y-axis, which is right here. So that's going to be a horizontal line. It's going to be solid, and we need to shade up from that. So we have a very small region where everything is overlapping, and it kind of makes a triangle right here. So that represents all of our possible solutions right in there. So the last thing this question asks us is to give an example of 3 different purchases he can make. I'm going to give one, and then I want you guys to find another one. So one thing we can do is we can go just pick a spot in here. So I pick a spot in the shaded region, and I picked that one. So it looks like I went over 1, 2, 3. So that means I can get 3 bagels, or bagels, as apparently I wrote, and then I can get 1, 2, 3, 4 things of muffins. So that's an option. So I want you guys to find another point that exists in this triangle I just drew and write that out. Next, let's take a look at this next one. It says Rondell makes $10 an hour cutting grass and $12 per hour raking leaves. So $10 per hour cutting grass, $12 per hour raking leaves. He cannot work more than 15 hours per week. So we're going to graph 2 different inequalities. This is going to be a system. We want to determine how many hours he needs to work at each job so that he can earn at least $120 per week. So me, I'm a fan of money. So let's start by figuring out let's do like a money equation. Let's just start by doing a money equation. So we're going to look at any restriction that's in place of the money. So he's going to spend X hours cutting grass, and he's going to get $10 for that. So that's going to be X. And then Y is going to represent our raking leaves. So he's going to spend Y hours raking leaves, and he gets $12. And then he wants to make at least $120. So if he made more, he'd be a pretty happy guy, right? So we need to solve this for y. So I'm going to start by subtracting 10x from both sides. And then I get that 12y is greater than or equal to negative 10x plus 120. Then I'm going to divide both sides by 12. So then I get y is greater than or equal to negative 10 divided by 12. I want to leave that as a fraction. So really I have this fraction, negative 10 over 12. So I need to ask myself, what divides 10 and 12? Well, that's going to be 2. So this is going to turn out to be negative 5/6x as my slope. And then 120 divided by 12 is going to give me 10. So I'm going to go ahead and graph that line. So I'm going to cross the y-axis at 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 right here. And then I'm going to go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6. Okay, so then we're going to go ahead and I'm going to connect those with a solid line. And then we're going to shade up. Okay, so now what I want to do is I want to take, so that's my money restriction. So that's going to be kind of like our bottom. That's our minimum amount of money that we want to make. Now I'm also restricted by the number of hours I work. Okay, so I have X hours cutting grass, Y hours raking lawns, and that has to be less than or equal the 15 hours a week that I'm allowed. So I need to solve this for y. So I'm going to subtract x from both sides, and then I get that y is less than or equal to negative x plus 15. So we're crossing the y-axis at 15. So that's going to be right here. And then my slope is negative 1. So I'm going down 1, right 1, down 1, right 1. And then I'm going to have a solid line going down, and then I'm going to shade underneath that. Okay, so then my overlapping region is just this little kind of snippet inside of here. So I want to make it obvious that that's where my solutions lie. Okay, so let's go ahead and let's take a look at this one. So we want to look at graphing inequalities. Okay, so I'm going to move this up. So first of all, we're graphing 3 of them now. So let's take a look at where our solutions are going to be. So here I have that x is greater than or equal to 0. Well, here's 0 right here at the origin. Okay, so what I'm going to actually do is draw a vertical line through the origin. Remember that when it's just an x, it's going to be a vertical line. And I want greater than 0, which means I am going to span out going that way. Okay, so now let's take a look at this next equation, this one right here. So we need to solve that for y. So I have x minus 2y is less than or equal to 2. So I'm going to start by subtracting x from both sides, and I get negative 2y is less than or equal to negative x plus 2. Then I'm going to divide both sides by 2. Now, when I divide both sides by 2, I need to make sure that I flip that symbol. So negative x divided by negative 2, that's actually just going to become a 1/2 x. And then 2 divided by negative 2 is going to give me a negative 1. So this right here is the inequality that I'm going to graph. So I'm crossing the y-axis at a negative 1, and then my slope is 1/2. So I'm going up 1 over 2. Oops. Up 1 over 2. Up 1 over 2. So that's going to be a solid line, like so. And then when I look here, I notice at the very end that it's facing away, or towards the y, sorry, so I need to shade up. So right now that upper right-hand corner is what's our overlapping, but we still have one more equation that we need to do. So let's go ahead and do that. So we need to solve this next equation for y. Okay, so when we do that, I'm going to start by taking that 3x and subtracting it over to the other side. So then I get 4y is less than or equal to negative 3x plus 12. Then I'm going to divide both sides by 4, and I get that y is less than or equal to negative 3/4 x plus 12 divided by 4, which is 3. So I'm crossing the y-axis at 3. And then my slope is negative 3 over 4. So I'm going down 3 and right 4. So that's going to be a solid line between those 2 points. And then I'm going to be shading down. Okay, so this actually overlaps just in this little triangle right here. That's where all 3 of those colors are going to overlap. Okay, whoa. So that's your final answer for number 7. Last but not least, let's take a look at number 8 here. So let's go ahead and let's graph these. So first of all, we have that x is less than 2. So the first thing I'm going to do is find 2 on the x-axis. And since it's just an x, it's going to be a vertical line, and it's going to be dashed as well. And I want when x is less than 2. So when we have the vertical line, the less than is going to be going to the left. So I'm going to go ahead and draw that. The next thing I need to graph is that y is less than or greater than 1/4 x. Well, that's the same as 1/4 x plus 0. So that means I'm crossing the y-axis at 0, and then I'm going up 1 and over 4. Up 1 and over 4. So then I'm going to have a dashed line going through there. And since it's facing towards the y, I'm going to shade up. So that upper left-hand corner is what's overlapping right now. Now I need to graph this next one. So I'm crossing the y-axis at 9, which is just a little bit off my graph, okay? Then I'm going up 2 over 1. So since I can't go up 2, I'm actually going to go down 1, 2, and over 1. So that's going to be a point, down 2 and left 1. Going down and left is the same as going up and right, because 2 negatives equal a positive. So this guy right here, again, is going to be a dashed line, because there's no line underneath there. And it's facing the y, so we're going to shade up. So this tippy top triangle right here is our answer as of right now. So now I need to solve this last one for y. So I'm going to start by subtracting x from both sides. And then I get that 3y is less than negative x plus 9. Divide both sides by 3, and I get y is less than. When I have a negative x divided by 3, that's the same as a negative 1/3 x. And then 9 divided by 3 is 3. So I'm crossing the y-axis at 3. Come on. So when I do that, I'm going down 1, right 3, down 1, right 3. So that's going to be another dashed line. And then it's facing away from the y, so I'm going to shade below that. So there's just going to be this little piece right here that represents our entire solution. So I'm going to shade that in to make it really obvious. So that concludes your note video for today. Thank you for listening.